Science Fantastic with Professor Michio Kaku.
This is Science Fantastic with Professor Michio Kaku. On Science Fantastic, we profile the amazing, jaw-dropping scientific discoveries that are revolutionizing our world and touching our lives. And once again, in this hour is your hour. Okay, let's move right on to the first listener phone call.
Hello, Dr. Kaku. I listen to you on KNSI Radio, 1450 AM in St. Cloud, Minnesota. On July 4th of 1947, supposedly a spaceship landed in Roswell, New Mexico. And being that it's the 70th anniversary coming up, I was just curious your thoughts. Did that really happen? I enjoy your show. Thank you very much.
Well, a complete answer to the question of the Roswell incident would take up the entire hour. But let me just summarize, because on radio I've actually interviewed the leading skeptic and one of the leading promoters of the Roswell controversy. So let me try to summarize briefly their particular points of view. First of all, I had an official from the Air Force who came on radio. And he said that no, it wasn't aliens from outer space. First of all, it was basically a weather balloon. It was something called Project Mogul, and the weather balloon crashed. And some people thought that the debris left over from the crash was evidence of aliens from outer space. And therefore, there's nothing to worry about. There are no dead bodies of aliens. And we did not reverse engineer these things, the Air Force official said. But then we had the skeptic come on and say, wait a minute. If the Air Force is so confident that it was a weather balloon, then how come they tried to hide it? How come they tried to disguise it? How come they've been giving so many false press releases and false leads? How can we believe anything that the Air Force says, given the fact that they've been changing their story all these years? Well, the Air Force person came back and said, okay, he'll admit that, yes, the Air Force has been changing its position, but there's a reason for that. And the reason is the Air Force actually allowed a lot of the Roswell stuff to get out of control because they were testing advanced weaponry. For example, the stealth bomber. Also, the flying wing. Different experimental aircraft were being experimented with. And, of course, you can't experiment with these aircraft over civilian cities. You want to do it over a desolate area, and that's where Roswell came in. So the Air Force person said, yes, the Air Force has been sending out fake press releases. The Air Force has been trying to cover up the fact that it was, in fact, secret missions like the stealth bomber, the flying wing, and other experimental designs that they were playing with. So, therefore, he said, it's still not a flying saucer. Well, then, the promoter of the Roswell incident comes back and says, well, we now know that the United States Air Force and military were actually dumping radiation into people's backyards. How can we believe the government if the government has been secretly releasing radioactive materials, radioactive uranium, into people's backyards without their permission? This was revealed by several newspapers in Albuquerque about 10, 15 years ago, made big national news. The fact that one of the reasons why there was this incident at Roswell is because the Air Force was secretly, the United States military was secretly releasing radioactive materials to test how far they would disperse into the environment. Well, this, of course, was very embarrassing to the Air Force and the military, but they still claim it was, in fact, not a flying saucer. Well, then the Roswell person came back and said, well, there are eyewitness accounts. Eyewitness account, there one nurse who claims to have actually seen the alien with big eyes on a stretcher, and therefore an eyewitness account indicates that there was an alien that was seen there. Well, the Air Force person came back and says, come on, what really happened was the United States Air Force was testing what happens if you jump out of an airplane miles above the surface of the Earth in order to test what would happen to astronauts. And so in one test, there was a test pilot who survived this very long jump, but he did sustain damage. Basically, when you're exposed to very low pressures, the blood inside your body begins to expand, and it caused him to have a very swollen face. And the Air Force even released a picture of this poor test pilot, showing that he looked very much like an alien. His face was totally swollen. His eyes were bulging out because of the fact. And so, in other words, the famous picture of the aliens that you see on every cereal box and every notice about the Roswell incident is really based on an actual photograph of a test pilot as he was jumping out of an airplane miles above the surface of the Earth in an experiment. Well, as you can tell, the debate went back and forth for a full hour. Back and forth, back and forth. Now, the average listener listening to this might be a little bit dazzled by the incredible flood of information. But let me try to summarize. First of all, the Air Force has now come out with a book that goes through the Roswell incident, the book that then debunks point by point, all the different so-called eyewitness accounts of seeing aliens from outer space and so on and so forth, saying that it was basically Project Mogul. It was basically a weather balloon that crashed. Okay, that's the Air Force position. Then the position of the true believers is, well, why should we believe anything? The Air Force admits, the government admits that it's been lying all these years about Area 51, about Roswell. The Air Force and the military now admit that, yes, they did plant false stories. They admit this now to cover up the fact that they were doing unauthorized experiments on radiation that was basically dumped into the air over people's backyard to test what would happen in an actual nuclear war. So after everything was said and done, well, I think it was a draw. That is, tit for tat, you could make an argument that the Air Force position is credible. They were able to rebut every single statement made by the true believers. However, the true believers don't believe any of it because the Air Force and the military has been lying to us all these years. Now, however, if you have been abducted by a flying saucer from outer space, I advise you one piece of advice. Steal something. I don't care what it is, a paperclip, a chip, steal something. So afterwards you have something tangible to say to the press. So often we get emails from people saying that, yes, they've been abducted by aliens from outer space, hideous experiments were performed on them, and they want to tell the world. But you see, there's no evidence one way or the other. We could settle the whole thing right now. If you have alien DNA, if you have an alien chip, an alien paperclip, I don't care what it is, alien technology with alien metals, that would end the thing right there. Otherwise, we're left with hearsay. Okay, let's move right on to the next listener phone call.
My name is Bob. I'm calling from Minnesota, and I was just wondering, how would you break down a neuron, and what is an atom? And I think your show is great. You guys have a wonderful day.
Okay, great. Well, the word atom is Greek for cannot be cut. A means cannot or no, like atheist means you do not believe in God, for example. A means you cannot, and tum means cut. So atom means you cannot cut it. In other words, it's the smallest unit of matter, said the Greeks. Now, how do they argue that? They argue that by looking at a gold ring. If you look at a gold ring over the years, over the decades, it begins to wear down. It gets smaller the older it is. But on any given day, you cannot see any of the gold being released by the ring. Therefore, said Democritus, there are invisible things called atoms beyond which we cannot cut that make up everything. That's the atomic theory. And the atomic theory is great because it explains the laws of gases. It explains the properties of liquids. It explains pretty much what we see with ordinary matter, the shape of crystals, the fact that we have phase transitions between gas and liquid, all the basic fundamental properties of matter can be more or less explained by the atomic theory. Now we know we can smash atoms apart, and inside the atoms there are subatomic particles. But then the question is, we now have hundreds of subatomic particles. In fact, when I got my PhD from Berkeley years ago, I had to memorize the names of all these subatomic particles, hundreds, thousands of subatomic particles. And to get a PhD, you have to memorize the names of all of them. Well, today we think that all of them in turn can be summarized by a string. They're nothing but vibrations of a tiny string. And so in the future, I would hope that if you get your PhD from Berkeley, all you would have to do is say, string theory, and you would get your PhD. So the atom is no longer the smallest constituent. We really don't know what is the smallest object, but the leading theory right now is that it's a vibrating string. Then we have neurons. There are 100 billion neurons inside your brain, as many neurons as there are stars in the Milky Way galaxy. And a neuron is more or less like a transistor. It's a relay that allows you to send signals from one part of the brain to another part of the brain and control that process. So the neuron is like a gate, and that's what a transistor is. A transistor is a gate that controls the flow of electricity. You can shut it off or turn it on. If you turn it on, you get symbolically the number 1. If you shut off electricity, you symbolically get the number 0. That's binary, and that is how the brain calculates. The brain uses the fact that it can shut off electricity or turn it on, and that allows the brain to calculate. And so the brain would be, in some sense, the smallest unit of brain activity, the size of a cell. Okay, well, let's move right along to the next listener phone call.
Yes, my name is Carl, calling from Pottstown, Pennsylvania, listening on 8:30 a.m., and I was wondering if you could help me with an answer to this question. What happens to an object when it approaches the speed of light? Does it simply stop accelerating?
Well, it turns out that you cannot reach the speed of light. However, with our atom smashers, we can go to 99.99999% the speed of light. So as you get closer and closer to the speed of light, it requires more and more energy to keep you going, but you never break the light barrier. Your mass gets heavier, time begins to slow down, and your spatial dimension begins to get compressed. So if you were to hypothetically hit the speed of light, which you cannot do, you would be infinitely flat, infinitely heavy, and time would stop. Now, obviously, these three things cannot happen. So you cannot reach the speed of light. However, with our atom smashers, we can accelerate protons to very close to the speed of light, but you can never break the light barrier. We've tried many times. Many times there's been an announcement that somebody broke the light barrier, but each time we find that, nope, you cannot. Now, there was an announcement about 5 years ago from Geneva, Switzerland, where some physicists said that particles went faster than the speed of light from Geneva, Switzerland to a detector in Italy. That made headlines, because these were reputable physicists saying that maybe Einstein was wrong. Well, of course, physicists redid the data, and they found that it was miscalibrated. It turns out the GPS system used to calculate the distance between Switzerland to Italy was miscalibrated. Human error. Now, the irony is the GPS system itself is using Einstein's theory of relativity. So, in other words, Einstein gets the last laugh. Sorry about that. After the break, we'll talk about speculative schemes to go faster than the speed of light. But at the present time, for us Earthlings, we cannot break the light barrier. Welcome back to Science Fantastic with Professor Michio Kaku. The lines are open. You can give us a call and make your comment or question about science. Well, we had a call coming in saying what happens when you approach the speed of light. First of all, you cannot break the light barrier. We've tried many times. Each time, Einstein is the cop on the block. Bizarre things happen. You get heavier. Time slows down on a rocket ship. And you get flatter and flatter. At the speed of light, you're infinitely heavy, time stops, and you're infinitely thin, none of which can actually happen. Therefore, you cannot break the light barrier. Now, there have been speculative schemes stating that maybe wormholes can do it. Yes, wormholes are a solution of Einstein's equations. In fact, they were discovered by Einstein himself in 1935 with his student, Nathan Rosen. That's why we physicists call it the Einstein-Rosen Bridge. Now, it takes an incredible amount of energy to open this gateway, basically a black hole. That is, a collapsed star. Tremendously heavy, and you need negative energy to stabilize it. So at least on paper, if you are a very advanced civilization, what we call a Type 3 civilization, you might have enough energy to open up a gateway through space and time and take a shortcut. Go faster than the speed of light by taking a shortcut between A and B, sort of like a subway system between A and B that allows you to short-circuit ordinary space. The problem is, well, we don't know how to manipulate the energy of a black hole. We're not there yet. However, if you get my book, Hyperspace, you'll find out some of the schemes that have been proposed by Earthlings to break the light barrier using what are called wormholes. Still speculative, but you can read about it in my book, Hyperspace. Okay, let's move right on to the next listener phone call.
My name is Clark. My city is Lake Ozarks, Missouri. My question is, do you think cars will fly in the future, as is all light?
Well, the answer is yes. In fact, they can fly today. Now, a lot of times people come up to me and say, Professor, where's my flying car? Huh? Didn't you guys predict flying cars? Well, where's my flying car? First of all, we physicists never predicted flying cars. They were predicted by cartoonists. However, that doesn't stop engineers from building them, and yes, indeed, we can build flying cars. In fact, I even had a guest on my show, Paul Muller of Muller Industries, who is marketing a flying car. In fact, Uber announced that in Dallas, Texas, and in Dubai, in the United Arab Emirates, they're going to field the fleet of flying cars. Now, what do these cars look like? Well, there are two types of flying cars. One of them has a gigantic fan underneath the car, so it hovers like a helicopter. The other one looks like, well, a mini jet. It actually has mini wings and mini jets, and it actually looks like a small toy version of a jet airplane. So they actually exist. So what's the catch? The catch is, well, first of all, cost. They're very expensive, hundreds of thousands of dollars. They're very fuel inefficient. But hey, that doesn't stop Uber from making plans to begin the process of marketing a fleet of flying cars. Also, regulations. We have very few regulations that license these things, and so safety is a problem, and congestion is a problem. But they're technical. Sooner or later, the law will catch up, and they'll begin the process of licensing and regulating flying cars. But look, if you have a spare $100,000 left over from hitting the lottery, then yes, you may want to pick up a flying car. They do exist. They are commercially available. They're not very efficient, and they're very expensive. I warn you. Okay, let's move right on to the next listener phone call.
My name is Craig. I'm calling from Palmer, Michigan. My question is about the common phrase called quantum leap. When an electron absorbs a photon and jumps up to the next energy shell, does it actually leap, or does it physically move through space or whatever is there to reach the next shell, or does it magically disappear and reappear in the next shell and not exist along the way? Thank you.
Well, that's a mouthful, but I'll try to answer that. But before I do, I forgot to mention something about the previous phone caller. He asked about flying cars. I forgot to mention another aspect of science fiction, and that is jetpacks. Yes, you too can fly in the air like Buck Rogers. They do exist. In fact, it was the Nazis during World War II that actually used jetpacks for its soldiers. Many times during World War II, the Nazi army would encounter bridges that were blown up by the Allies. So what do? You can't drive a truck over a bridge that's been collapsed. So you put a Nazi soldier with a jetpack, and he hops right over the bridge. Well, yes, they can work. However, there's a catch. There's always a catch somewhere, and that is the hydrogen peroxide that you use in your jetpack only works for about 30 seconds to about a minute. Now, many times, like during the Olympics, many times there have been demonstrations of jetpacks. And you say to yourself, wow, look at that man flying in the air. The 1986 Olympics featured a man with a jetpack. But in the newsreels, they only show him for the first 30 seconds. Because after that, he comes crashing back down on the earth. And so you need a portable jetpack. That is a portable energy power supply, a battery of some sort. Right now, batteries are not powerful enough to sustain a jetpack, and hydrogen peroxide, the fuel of choice, only works for about 30 seconds. And so, in other words, it's an engineering problem, not a physics problem. We can build jetpacks, but it's an engineering problem to create a jetpack that can fly for long periods of time. Then we had another call coming in about quantum leaps. Yes, quantum leaps happen all the time. Every time you look at an incandescent light, for example, that shoots electricity through a gas. The electricity then sends electrons to a higher level, and then when the electron comes back down again, it releases a photon. So these are called quantum leaps. There was even a TV program about quantum leaps. And the caller asked a question that's quite profound. What happens during the quantum leap? Can you actually see the atom go from point A to point B? How does that quantum leap happen? Well, the short answer is we don't know. We can calculate with it. That is, we have the wave of the electron in one state, a wave of the electron in another state, and using mathematics, we can then calculate the probability of going from state A to state B, which gives us an incandescent light bulb. So we know how to calculate these things. But the question is, well, what did the atom do? Did the electron go whizzing from point A to point B? Did it somehow make a leap? We don't know. All we know is we can take the wave of the electron in the initial state, take the wave of the electron in the final state, and calculate how the transition probability of going from state A to state B. So why can't you tell whether the electron actually went from A to B? Because of the Heisenberg uncertainty principle. The Heisenberg uncertainty principle says you can never know, no matter how delicate your instruments are, how sensitive your apparatus is, you can never know precisely how these electrons make their leaps. Sorry about that. The Heisenberg uncertainty principle basically makes it impossible to tell exactly how electrons go from A to B, which means that electrons, in some sense, can be two places at the same time. Now, why did Einstein hate this idea? He hated this idea because it meant that you can never know exactly where an electron is. Now, Einstein thought, this is stupid. I mean, the electron is either here or there. It cannot be two places at the same time. Well, actually, it can. It turns out that at the quantum realm of the atom, electrons can be in multiple states simultaneously. Now, some of the greatest minds in modern physics have grappled with that question. How can an electron be in two states at the same time? And there is no uniform answer to this. Even today, my friends who are Nobel Prize winners, even today they debate this. Now, the latest theory, which is advanced by many of my friends, like Frank Wilczek of MIT, Nobel Prize winner, Frank says that the easiest way to resolve this problem of the quantum leap, the question that atoms can be two places at the same time, is to assume that the universe splits. In one universe, you have the electron in point A. In another universe, you have the electron in point B. So, all this quantum fuzziness can be resolved by the many worlds theory. Now, some people say, oh my God, that's even worse than before. Before, we simply didn't know where the electron was. Now you're telling me that the electron can be both places at the same time in two different universes. Well, yeah, that's right. The leading theory that most of my friends, many of the Nobel Prize winners, the leading theory that they believe in is that the universe splits in half. In one universe, perhaps you had Abraham Lincoln who died at the Ford Theater. In another universe, a parallel universe, perhaps that gun by John Wilkes Booth never fired because of a quantum defect, because the gunpowder didn't ignite properly. There was a misfire, and Abraham Lincoln never died. Well, your mind goes spinning thinking about this, but hey, it's called quantum physics. And if you want to know more about these things, get a copy of my book, Parallel Worlds, a whole book devoted to trying to tease apart that paradox of how you can be two places at the same time. Okay, well, let's move right on to the next listener phone call.
Deborah, I just wanted to know, why hasn't the hydrogen cell taken off for supplemental fuel with cars? I've seen plans on the internet for building your own. I didn't know if they were safe, but I know that even the battery, when it's charging itself, produces a small amount of hydrogen anyway that normally is a hazard, but could be used as a clean-burning supplemental fuel.
Okay, well, you ask a very important question. Some people think that we're going to be entering the age of hydrogen, that will have hydrogen fuel cells, that will have hydrogen in our cars, that will use fusion from the sun, which is based on hydrogen. So what's the problem? Well, the problem is basically cost. Yes, it is possible to make a fuel cell car. Toyota has one, for example. It's a great car. It's all electric, and the waste product from the exhaust tail is pure water. In fact, in principle, you can drink it. Think about that, drinking the waste from a car. That's impossible with a standard car, but you can do that with a hydrogen fuel cell car. So let's break it down. First of all, some people say hydrogen is volatile. It will explode. Therefore, that's a problem. Yes, that's a problem, but look at cars today. Cars today also explode, and we live with that fact that cars explode every day. We just live with it because cars are so convenient. Second of all, you would have to have a hydrogen refueling station every few blocks. And many people say that's not possible. Well, take a look at fossil fuel cars. We have gasoline pumps every few blocks. So, in other words, hydrogen fuel cells, the criticisms against hydrogen fuel cells are identical to the criticisms used against gasoline-fired cars. So, why don't we have fuel cell cars? Because of, well, cost. They have to be mass-produced. We have to get the infrastructure ready for it. And remember, the infrastructure for gasoline-fired cars took decades to get the basic infrastructure for hydrogen, for gasoline-fired cars. And fuel cell cars, well, the infrastructure does not even exist yet at the present time. So how do these fuel cell engines work? How come they're so expensive? Well, in high school, you probably remember that you can get a tank of water and put 2 electrodes in that water, and one electrode becomes the anode, one electrode becomes the cathode. Hydrogen accumulates in one electrode, and oxygen accumulates in the other. That proves that water is H2O. That is, water is made out of 2 atoms of hydrogen and 1 atom of oxygen. That's called electrolysis. You can also do the reverse process. When hydrogen and oxygen combine, it releases energy. In fact, I still remember, I'll never forget this, I was in junior high school where my science teacher demonstrated this thing. And then, well, like an idiot, he got a match. He got a match, and because there was hydrogen and oxygen, a match would ignite it. Well, what happened was it exploded. One person in the classroom got sent to the hospital. I'm not kidding. This actually happened when I was around 7th grade. One of the kids in that classroom was actually sent to the hospital because the glass container exploded. Well, of course, we don't want to have that in a car. We want to have that done safely in a hydrogen fuel cell. And again, they exist. They're just very expensive. But one day we may have hydrogen refueling stations on every few blocks.
Science Fantastic with Professor Michio Kaku.
This is Science Fantastic with Professor Michio Kaku. On Science Fantastic, we profile the amazing, jaw-dropping, scientific discoveries that are revolutionizing our world and touching our lives. And in this hour, it's time for you to participate. It's time for you to get in on the fun. Okay, let's move right on to the next listener phone call.
This is Gloria, Pottstown, Pennsylvania, WEEU. I was wondering, with these black holes, why can they not rig up a probe and send it into the black hole with a camera? Pretty much like they have those on-man things with the Army, that they can take pictures, send it back, and then we can find out more of what is going on in the black hole. Thank you. Bye-bye.
Well, you ask an excellent question. First of all, we do exactly that to the planets and the moons. We take a camera, put it onto a rocket, and we actually send them into Jupiter and Saturn and different places around the solar system. And as a consequence, we know an awful lot about atmospheres, about the surface, about the structure of the planets because we have probes with cameras. However, when you talk about black holes, there's a catch. There's always a catch someplace. First of all, the nearest black hole is many light years away. For example, we have a raging black hole at the center of the Milky Way galaxy. Tonight, if you go outside, look in the direction of Sagittarius. In that direction, there should be, by rights, a fireball. There should be a fireball there, which is the galactic nucleus, the center of the galaxy. You can't see this fireball because it's obscured by dust clouds, and the disk of the galaxy, yes, has lots of dust. In fact, that's where we come from. We are made out of galactic dust, but it's a nuisance if you want to see the center of the Milky Way galaxy. At the very center, there's a raging black hole. It weighs 2 million times the mass of the sun. So what's the problem? The problem is these black holes are located hundreds, thousands of light years away, and each light year is about 6 trillion miles. So in other words, we're not going to go to any black hole anytime soon. They're simply too far because the universe is too big. Now, that doesn't prevent us from dreaming about sending a probe or a camera into a black hole. Now, the next best thing you can do is to get a computer to simulate Einstein's equations for a black hole. And we've done that. If you saw the movie Interstellar, starring Matthew McConaughey, they actually take a rocket and go through the gateway, the wormhole, to a black hole. And using computers and Einstein's equations, you can actually see what a hypothetical journey would look like. All sorts of bizarre things happen when you fall through the wormhole, connecting you to the black hole to perhaps maybe another universe. So if you see the movie Interstellar, it gives you the best computer rendition of traveling through a black hole because the nearest black hole is simply too far away. Trillions upon trillions of light years, and we're not going to go that distance anytime soon. Okay, let's move on to the next listener phone call.
Hi, my name is Jen. My question was, how many monkeys have to evolve to create a whole other species?
Well, that number depends upon the circumstances and the species you're talking about. First of all, we have to even define what a species is and how we tell two species apart. And this is where biology starts to get a little bit fuzzy, even in the definitions of species. Usually, biology books say that when two groups of organisms can no longer mate, and produce viable progeny, that's when these two groups have separated and they have speciated, and they're no longer part of one species. Okay? Now, there's lots of ambiguity. Okay? For example, what about the donkey and the mule? And what about the liger? The liger is a cross between a tiger and a lion. Believe it or not, you can mate a tiger and a lion and come out with a liger. So, how do you define two different species, given the fact that they can, in fact, mate and produce progeny? But these progenies are usually sterile. Therefore, you cannot create a third distinct species by mating two species, even though they are very close. Now, take a look at our own species, the Neanderthals, for example. Most people would say, and many biologists would say, that the Neanderthal is a separate species from humans. How come we know that? Because we can't mate with them. Well, that's been disproven. In fact, on our airwaves, I've actually interviewed the man who did it. The man who took Neanderthal skeletons, about 6 of them, and extracted usable DNA from the Neanderthals, and from that created a composite genome. That's incredible. A composite genome of the Neanderthal man. And the Neanderthals, do they constitute a new species, different from us? And the answer apparently is, well, we don't know. Maybe no, because according to the person I interviewed, he sequenced the genes and found there is about a 1% overlap. Incredible. A 1% overlap between our DNA and Neanderthal DNA. So in other words, our ancestors mated with them. This is rather shocking, because we used to think that Homo sapiens are all high and mighty, and that we are unique, and that we're at the top of the evolutionary chain, and we now realize that we share DNA with the Neanderthals. In fact, certain characteristics that we shared are very interesting. One of them is to withstand cold climates. It turns out that Neanderthal DNA might have been useful because the Neanderthals lived in iced areas of northern Europe much longer than we did, and they were better adapted to the Ice Age than Homo sapiens. Also, he said, certain characteristics may be traced to the Neanderthals. For example, red hair. There's indication, even though it's not conclusive yet, he said, there are indications that red hair is a byproduct of mating with the Neanderthal. And so to sum up, usually biology books say that you have to speciate when you can no longer mate with the other species. But then what about the Neanderthal? Okay, let's move right on to the next listener phone call.
I'm calling from Sterling, Massachusetts. My question is about the cosmic background radiation, which is due to the Big Bang. The background radiation is continuous, and the Big Bang was an explosion. So could you resolve that paradox? Thank you.
Okay, first let's define some terms. First of all, when you turn on your radio, you, of course, get static if you're between stations. Where does that static come from? Well, it turns out that a lot of it comes from Jupiter. Believe it or not, Jupiter is quite radioactive, quite energetic, and we now know that a fair amount of the static you pick up on radio comes from the planet Jupiter. What about the other pieces of static? Well, some of it comes from the Big Bang. Genesis, the origin of the universe. You're actually listening in on remnants, an aftershock, the afterglow of the creation of the universe itself. So how does that work? Well, as the gentleman pointed out, the Big Bang was just basically one gigantic fireball that erupted, and gradually over time it began to cool off and created the stars and the galaxies that we see around us. However, about 300,000 years after the Big Bang, there was a very important event that happened, and that is that atoms could form for the first time. You see, before 300,000 years ago, before the incident of the Big Bang, out to 300,000 years, it was too hot. The universe was too hot. The universe was opaque. You could not see very far if you were alive during that time. The universe was very opaque, and it was cool enough, 300,000 years after the Big Bang, for atoms to condense, for electrons to go around hydrogen. That point is the radiation picked up by our satellites. It's the radiation picked up by your radio. So your radio is picking up radiation 300,000 years after the instant of creation. And that resolves the problem. The gentleman asked the question, the cosmic background radiation is smooth, but the Big Bang was a violent event. How do you reconcile the two? Well, the Big Bang came first. It was that violent event which sent all the gaseous materials out into outer space, but it took time. It took time for that gaseous fireball to cool down to the point where atoms can form. At that point, space becomes transparent. Now, we've always thought of empty space as being a description of the universe, but that's not always true. In the first 300,000 years of our infant universe life, the universe was basically opaque. You couldn't see very far. 300,000 years after the Big Bang, the first atoms began to condense. The familiar atoms, hydrogen and helium, lithium, began to condense out of the primordial gas that came out of the Big Bang. And that primordial radiation, 300,000 years after creation, as atoms were condensing, that is what you pick up when you look at the cosmic microwave background, which is the echo of the Big Bang. Not the Big Bang itself. It's the echo of the Big Bang 300,000 years after the instant of creation. Okay, well, let's move right along now to the next listener phone call.
Hi, this is Paula. I'm calling from Camdenton, Missouri, and I would like to ask, how long does it take for a stem cell and tissue to form an ear? How long does it take from start to finish to put together the ear or any other part? Thank you very much.
Okay, well, first of all, let me explain how we do it, and then I'll ask you a question of how long does it take. First of all, stem cell technology is very primitive, not that advanced, but not even using cells that are not stem cells, scientists at Wake Forest University have been able to create all sorts of human organs, not just the ear. At the present time, not even using stem cells, ordinary cells that have been treated specially, we can create carbon copies made out of plastic of ears, noses, cartilage, skin, blood vessels, heart valves, bladders, and windpipes. That is incredible. It's almost like walking through Frankenstein's laboratory. I had a chance to take a film crew from the Discovery Channel. We flew down to Wake Forest University in North Carolina, and we visited the laboratory of Anthony Ataya. Maybe you've seen some of his work on science specials, and you sort of feel like, feel like Frankenstein's doctor walking through the hallway at Wake Forest University, looking at jars containing human organs, human hearts, human livers. Kind of eerie. But then you realize that, these are mock-ups. These are practice attempts to create kidneys and livers and hearts. Because right now we can't do that. Right now we can basically create tissues made out of basically one type of tissue. However, the liver and other organs of the body require many different kinds of tissues, and that's where it takes time. Now, the caller asks, first of all, how long does it take to grow an organ? The answer is a few weeks. You can grow a whole ear in about 2 or 3 weeks in the laboratory. In fact, there's even the program that I hosted for the Discovery Channel called 2057, talking about the future, where we actually visit these laboratories and interact with the scientists who are, in fact, creating bodies of the future. Now, to create a clone of the brain, of course, takes a lot more effort, but it turns out that already with today's technology, we can already begin the process of creating organs that are almost indistinguishable from human skin, bone, cartilage, noses, ears, heart valves, and bladders, and even windpipes. Truly miraculous. Okay, let's move right along to the next listener phone call.
Hi, my name is Rick. I'm calling from Interstate 15 south of Las Vegas, driving a truck. My question is a neutron bomb a neutrino emitter, or does it create neutrinos? If so, if you have a neutrino detector and you are setting off a neutrino emitter, wouldn't you be able to detect things on the other side of whatever it is you're trying to look into, such as you suggested the Earth?
Well, first of all, let's talk about the neutron bomb, and then let's talk about neutrinos. First of all, the N of the neutron bomb does not mean neutrino. It means neutron. It is a neutron bomb, not a neutrino bomb. In fact, in physics, we use the neutrino bomb as a joke, because if a neutrino bomb goes off, what happens? Nothing. Absolutely nothing. Because your body is being penetrated by billions upon billions of neutrinos from the sun, black holes, and whatever, and you don't feel a thing. Neutrinos, in fact, can go through light years of lead, and not even get absorbed. That's incredible. Think of our solar system made out of solid lead, and you can shoot a beam of neutrinos right through it. So a neutron bomb, the N stands for neutrons. They, in turn, can do a lot of damage. A lot of the damage from bombs actually comes from neutrons. So the N bomb, the neutron bomb, neutrons do cause a lot of damage. And so the neutrino is emitted as a byproduct of the fusion process, but the neutrinos are extremely ephemerate. That is, they go right through matter without hardly noticing it. And that means you can send it right to the center of the Earth. One day, perhaps we'll have neutrino detectors that can detect earthquakes on the other side of the Earth, because they go right through the Earth as if the Earth is made out of nothing. So neutrinos are quite different from neutrons. So let me sort of explain how they work. First of all, hydrogen bombs have gone through 3 different stages. Stage 1 of a hydrogen bomb, they were so big, gigantic, that they had to be placed on a ship in order to deliver it to its target. So the first generation hydrogen bombs were kind of useless in terms of warfare. They were built in the 1950s, huge, gigantic bombs, 1,000 times more powerful than the Hiroshima bomb, but they were so big and clumsy that you couldn't use them in an actual war. Second generation hydrogen bombs are hydrogen bombs which are MIRVs, small, compact, and you can put 10 of them in the nose cone of a Minuteman missile. These are called Type 2 hydrogen bombs. Then there are Type 3 hydrogen bombs, which are designer hydrogen bombs that are used for particular purpose, like to be used in the battlefield in the desert, in the jungle, in the North Pole, in outer space. Star Wars type weapons would be a typical Type 3 hydrogen bomb. Then there's a neutron bomb. It's a 2.5 generation bomb. It's halfway between a MIRV and a designer hydrogen warhead. So the neutron bomb is a 2.5 generation bomb. Now, how dangerous is it? Well, the neutron bomb is sometimes called the landlord's bomb. Because if a landlord wants to evict the tenants, you want to preserve private property but kick the tenants out. Well, that's what the neutron bomb does. The neutron bomb goes right through houses. It goes right through inert material. But when it hits tissue, it hits human flesh, it destroys it, causing mutations, causing burns, and things like that. And so that's why they call the neutron bomb the landlord's bomb, because it's a clever way to evict the tenants by vaporizing them, but without hurting your private property. And that, of course, is, again, different from the neutrinos, which are very elusive. They can go right through the center of the Earth. At this very minute, right now, as you're listening to this radio show, you are being hit by neutrinos coming from the ground because they came from a black hole on the other side of the universe. So think about this. Right now, you're being hit by radiation coming from the ground, going up through your body, and that is how elusive the neutrino is. Now, why use it? Because one day we may have neutrino telescopes that may give us pictures of the inside of the Earth. X-rays can't do it. Neutrons can't do it. They cannot penetrate. They cannot penetrate to the center of the Earth. But neutrino telescopes can. So what's the catch? The catch is that neutrinos are so elusive that you can go right through the entire Earth and not hit anything at all. So therefore, neutrino telescopes, even though it's a great idea, are not practical because they're simply too penetrating. Okay, let's take the next listener phone call.
Trevor from Eager, Arizona, 1400 a.m., and I'd like to know if there's a boundary to the universe, because the stars, there's places where we see no stars, and it's just black. And I'd like to know if there is a boundary to the universe.
Well, you ask a little bit of an embarrassing question, because the short answer is we're not really sure. However, we do know that the universe is more mysterious than we thought. First of all, there are these black spotches where there's simply no stars at all. Now, the Big Bang Theory says that the universe should be uniform. No matter where you look, you should see even density. But we do have these splotches out there. Some people think they're remnants of a colliding universe. So how come the universe has these holes in it where there are no stars? Well, the short answer is we don't know. But there's a theory that says that maybe it's the scar left over from colliding with a parallel universe. This is taken actually very seriously. I've seen talks on this. Because the leading theory of the Big Bang is called inflation, proposed by my colleague, Alan Guth of MIT. And in inflation theory, the universe blew up in a Big Bang, but Big Bangs can happen more than once. In fact, they happen all the time. Each time a Big Bang happens, it creates a baby universe that has budded from our universe. Well, if you can have universes budding from our universes, then obviously you can also have universes colliding with other universes, and that may explain some of these black splotches. Maybe they are remnants of an ancient collision that we had with another parallel universe. So we now believe that our universe is a bubble, but this bubble can have baby bubbles. And it can have parallel bubbles. And when these bubbles collide, or when these bubbles peel off baby universes, then that's why we have the Big Bang. In other words, the Big Bang is probably the remnant of an ancient collision with another universe, or perhaps it's the budding of our universe into a baby universe. All of this, of course, is theory, but these theories are being taken very seriously. And then the caller asks another question, where is the boundary of the universe? Well, if the universe is a bubble, and we live on the skin of the bubble, then the bubble has no boundary. In other words, in 2 dimensions, a bubble is infinite. You can go around the bubble an infinite number of times and never meet the end of the bubble, because, of course, it is a bubble. So a bubble in 2 dimensions is infinite. But in 3 dimensions, obviously, is finite. It's a bubble, for God's sake. So that's how you get around the fact that you have a universe with no boundary. So we don't think the universe has a boundary. That would violate Einstein's equations, which says the universe must be smooth like a sheet of paper or like a trampoline net. And having a boundary would violate that principle. So in other words, to answer your question, the universe probably has no boundary at all. The boundary, if it does exist, exists in another dimension, a dimension we cannot see, a dimension that swallows up our universe. So our universe could be a bubble floating in a higher dimension. Okay, well, let's move right along to the next listener phone call.
Hi, my name's Alan from Austin, Texas, and I'm listening through the internet. And my question is, as far as wind energy goes, why can't they, the big problem is storage or transmission. Why can't they use the wind to convert water into hydrogen at the location and then transport the hydrogen and use that for energy somewhere else?
Well, you ask a very interesting question because in principle, yes, everything you just said is doable, but there's always a catch, right? The catch is cost and inefficiency. You see, every time you convert one form of energy into another form of energy, you lose some energy. That's called the second law of thermodynamics. It means that there's always waste heat generated because you're transforming energy from one form to another. Therefore, you have to worry about losses. You have losses every time you transfer energy from one form to the other. Hydrogen, you can ship and use that for times when, let's say, the sun doesn't shine or the winds don't blow. Well, yes, you can do that, but the problem is you lose energy every time you convert energy from one form to another. So, for example, to convert wind to electricity, yes, you can do that. You lose a little bit of energy there. Electricity that can then be used to break up water for electrolysis, that takes waste energy. And then you can use that to transport hydrogen. Sounds great, but you lose energy every time you make that conversion process. And that's the basic problem. Let me give you another example of how waste energy determined the nature of the power grid. About 100 years ago or so, Nikola Tesla and Thomas Edison had a rivalry, and that was would AC or DC transmit energy. Tesla said AC, and that's what we use today. We have 60-cycle AC power in our home. Edison said no, direct current. Electrons moving in one direction, not going back and forth, back and forth. Well, who was right? Well, obviously, Tesla was right. But why was Tesla right? Because of energy loss. It turns out that AC current can travel longer distances and have less waste energy than DC. In other words, it's economics. The economics eventually killed Edison's idea of direct current. People call that the battle of the currents, or the battle of the geniuses, Nikola Tesla versus Thomas Edison. Both, of course, were giants in their field. So, the same thing with wind power and solar power. We want to have as few translations of energy from one form into another as possible, because each time you do that, you lose energy. So the leading way to do it, I think, is with ordinary batteries. If the sun don't shine, you want to have batteries that can store energy so that at nighttime you can use the electricity stored. Utilities will love that, because if we have super batteries, like what Elon Musk is proposing, then we don't have to have power plants that have to go to peak power and produce peak winter energy. It's a waste of time, because most of the time a power plant is not using peak power consumption or peak winter. So what's the way to smooth out the energy cycle? Batteries. But batteries are getting more efficient every year. Battery prices drop about 17% a year, tremendous drop in the price of batteries, meaning that in the future, batteries could be the way to go. Okay, let's take the next listener phone call.
This is Jay in Kansas City. I was wondering if you might explain a little bit about how integral fast reactors work and maybe comment on their safety. Thank you, Doctor.
Okay, well, we have with us today light water reactors, reactors that use uranium and are cooled by water. You got that? So these are the commercial reactors that we see today. However, there's another kind of reactor called hard nuclear reactor, which is based on plutonium, and they are fast reactors. Fast meaning the speed of the neutron. Now, why is there some concern about plutonium-fired fast reactors? Because plutonium is much easier to detonate off of than the uranium that we use. The uranium that we use in reactors today is 3% enriched uranium. That's too low. It turns out that bomb-grade uranium has to be enriched to 90% in order to make an atomic bomb. Therefore, commercial reactors of today, the uranium is simply not usable for a bomb. So fast reactors have also been looked at. Fast reactors, in some sense, create plutonium as well as use plutonium. They call it the Midas touch. Midas was the king who, when he touched anything, it turned to gold. However, one day he touched his daughter, and his daughter turned to gold. So there was a downside to that ability. So fast reactors, well, they operate on plutonium, not uranium, and they are recyclable. That is, you can create plutonium as well as use plutonium. So it's like the Midas touch, something for nothing. Well, of course, in nature, there's no such thing as something for nothing. That would also violate the second law of thermodynamics. So what's the catch? What's the catch with regards to fast reactors? And that is, you can detonate on them. You can actually build atomic bombs, because the threshold for the purification of plutonium is a lot lower than the threshold for purifying uranium. uranium has to be purified from 3% to 90%. That's what the Iranians are trying to do, by the way. They, of course, would like to go to bomb-grade uranium. Well, unfortunately, our time is up. Once again, you've been listening to Science Fantastic. This is Dr. Michio Kaku, inviting you to join us every week for a discussion of science as we probe the cutting edge of science.
Science Fantastic with Professor Michio Kaku.
This is Science Fantastic with Professor Michio Kaku. On Science Fantastic, we profile the amazing, jaw-dropping scientific discoveries which are revolutionizing our world and touching our lives. And in this hour, we're going to roam across the universe. We're going to bring on an astronomer, our friend Ken Roswell, author of a number of great books, including The Alchemy of the Heavens. And we're going to ask several questions. Are there twins? Twins of the Earth in outer space, perhaps capable of supporting life. And, for that matter, let's talk about an oddball star out there in the heavens called Tabby star. It's causing quite a bit of controversy in the astronomical community. Some astronomers have said that maybe it's a sign of intelligent life. Megastructures, gigantic machines, perhaps, circling around Tabby star. These are not science fiction writers or tabloid writers talking about this. These are professional astronomers that are scratching their heads saying, my God, what's happening in Tabby star? There's an object circling Tabby star that can dim starlight by 22%. That's astonishing. Even Jupiter, going in front of our sun, will only dim starlight by 1%. What could possibly dim starlight by 22%? In fact, if you know the answer, why don't you publish it? Get on the web, make an announcement that you understand why Tabby star is acting in such a bizarre fashion. Is it a megastructure? Is it a Dyson sphere? Is it evidence of extraterrestrial civilizations far beyond anything that we can muster here on the planet Earth? Or is it a comet storm? Maybe a smudge on the telescope? Well, quite frankly, astronomers don't know the answer. If you know the answer, why don't you publish it? So look it up, Tabby star. You can Google it and find out why astronomers are dumbfounded, at a loss for words. Is it a megastructure or is it just lint on somebody's telescope? So let's take a short commercial break, and after the break we're going to bring on Dr. Ken Roswell talking about extrasolar planets, aliens from outer space, and what's out there in this great universe of ours. Welcome back to Science Fantastic with Professor Michio Kaku. With us today is one of our favorite astronomers, Ken Roswell, astronomer at Berkeley, author of a number of great books, including The Alchemy of the Heavens. And there are just so many things happening in outer space. First of all, with regards to exoplanets. New exoplanets are being discovered almost all the time. They look very much like the Earth. So we're going to talk about super Earths that are found in outer space. And then we'll say a few things about that bizarre star out there. That starlight seems to be dropping even as we speak right now, and no one knows why. A few years ago, starlight dropped by 22%. That's an unprecedented drop, and some people are saying maybe it's the work of aliens from outer space. If we have time, maybe we'll say a few things about the sun as well. NASA has just announced a few days ago that it's going to send the Solar Probe Plus to the sun. So we'll say a few things about the sun and also a few things about Jupiter. There's a new picture of Jupiter that doesn't look anything like what we've accustomed to seeing when we look at the planet Jupiter. Okay, once again, our special guest today is Ken Roswell, astronomer at Berkeley, author of a number of great books, including The Alchemy of the Heavens. So, Ken, was it surprising to you that the closest star to the Earth, Proxima Centauri, has a planet going around it which is Earth-like? What are your thoughts?
Well, I think it's a really good news because this star is not very far. It's only 4.24 light years away. It's the star that we can travel to potentially in our lifetime. And the star, though, is very different from the sun. It's much fainter than the sun. It's a red dwarf star. And even though it's so close to us, it's actually not visible to the naked eye. It's one of 3 stars that make up the Alpha Centauri system. Alpha Centauri consists of 3 stars. The brightest is a star very similar to the sun, a yellow star. The second brightest is also rather similar to the sun. It's an orange star, and those 2 stars together are very bright in the night sky, although unfortunately they're visible mostly to people in the southern hemisphere. Most of us in the United States are not able to see Alpha Centauri. And Proxima Centauri is so faint that it was only discovered in 1915 by a guy using a telescope. So Proxima Centauri is a very different star from the sun. Nevertheless, as you say, we have discovered a planet that is just a bit more massive than the Earth going around Proxima Centauri. And this planet is much closer to its sun than the Earth is to our sun. But that's actually a good thing, because Proxima Centauri is so faint and so feeble. As a result of this planet being so close to its star, the planet is actually in the star's habitable zone. And so potentially, if it's got water, if it's got an atmosphere, it could have some form of life. And just to give you an idea of how close this planet is to its star, our Earth, of course, takes 1 year to go around the sun. The planet Mercury, which is the planet closest to the sun, takes 88 days to go around the sun. This planet just takes 11.2 days to go around Proxima Centauri. And so it's a lot closer to its sun than either the Earth or Mercury is to our sun.
Okay, well, a few weeks ago on Science Fantastic, we actually had some physicists talking about Stephen Hawking's proposal to send a probe to Proxima Centauri. The probe would not be like the Enterprise on Star Trek. It would be the size of a postage stamp, energized by 800 megawatts of laser power, blasting a small little computer chip all the way to the nearest star. Now, Ken, as I understand, Proxima Centauri b, even though it is Earth-like, even though it's in the habitable zone, orbits around a red dwarf. Tell us a little bit about red dwarfs, and some people think that maybe if you're too close to a red dwarf, you'll get hit with a lot of solar flares. So what is a red dwarf?
A red dwarf is a star that generates energy the same way as the sun, by converting hydrogen into helium at its core, but it had the misfortune of being born with a much smaller mass than the sun, between 7% and 60% of the sun's mass. And as a result, its nuclear reaction runs very slow and it's very faint and feeble. These, though, are the most common stars in the galaxy. The sun is not an average star, despite what you may have been taught in school. The sun is actually an above-average star. Most stars in the galaxy are red dwarfs, about 75% of them. So these are the most common type of star in the galaxy. And we now know that a number of them have planets, including Proxima Centauri. Now, you asked me about this project to send a spacecraft to the planet. Well, I think it's a wonderful idea, although do realize there's a huge challenge here. The farthest object that we have ever sent the spacecraft to is the planet Pluto, which the New Horizons spacecraft passed in 2015. Proxima Centauri is 7,000 times farther than the planet Pluto. So you can see the enormous challenge ahead of us. So even though it is the nearest star to the sun, it's still a long, long way away. Nonetheless, I welcome all these ideas for how we might send a spacecraft to Proxima Centauri, because the fact is we didn't really learn a whole lot about the planets of our solar system until we sent spacecraft past them. I mean, we had no idea really what Pluto looked like before the New Horizons spacecraft. We knew it had 5 moons. We knew how long it took to rotate and so forth. We knew it was cold, of course. But in terms of the actual details on its surface, we didn't know any of that prior to that spacecraft. And so likewise, this planet, which is so much farther away, we know very little about this planet around Proxima Centauri. It would be wonderful to have close-up images of this planet. And so I welcome all these ideas that are being put forth to send a spacecraft to Proxima Centauri's planet.
And Professor Landis, who we had on Science Fantastic a few weeks ago, was very careful to say that the project is going to cost $10 billion. It will involve creating a gigantic bank of laser beams concentrated on a small postage stamp chip that they would send to 1/5 the speed of light. So it would reach Proxima Centauri in about 20 years' time. So don't hold your breath. But we are talking about perhaps the first starship capable of reaching the closest star to the planet Earth. Now, Ken, we talked about red dwarf stars. Some people say that if you get too close to a red dwarf star, there are going to be a lot of solar flares. And as a consequence, life on such a planet could be problematic. What are your thoughts?
Well, there are a couple of problems with red dwarfs. One is just what you point out. Many of them are very active, and they have these big flares. And that could be damaging to any life on the planet. But on the other hand, maybe the radiation actually speeds up the evolution of life on those planets. We don't know. We here on Earth, it took us 4.5 billion years to establish intelligent life on the Earth. We don't know if we're fast or slow. Maybe around red dwarf stars, life proceeds faster. Maybe those flares actually help life, help speed up the evolution of life. And furthermore, life is pretty good at adapting to its environment. So I presume if life has arisen on Proxima Centauri's planet or on some of these other planets that go around red dwarfs, that it has presumably adapted to the harsher environment. And then there's a second problem with red dwarfs, and that is these, as you say, the habitable planets have to be very close to their stars, and as a result, the gravity of the star forces one hemisphere of the planet to forever face the sun, and the other hemisphere to forever face away. So one side of the planet has perpetual day, and the other side has perpetual night. And there's no reason you couldn't have life on such a planet, but it would be a rather different environment from the Earth, where, we go through cycles of day and night every day.
Right. And some people think that there's a narrow band, therefore, between night and day, a twilight zone, so to speak, where perhaps liquid water could exist, in which case there could be lakes and perhaps oceans on such a planet. But what are your thoughts? Is it possible, therefore, that if you're tidally locked to the red dwarf star because you're so close to it, is it possible, therefore, there could be a band, a twilight band, whereby life could be possible?
I think that's definitely possible. I think, in fact, the entire day side of the planet might be good for life. Obviously, different types of life. The warmer, the life that prefers the warmer temperatures would be on, the part of the planet that's directly under the star, and then life like, polar bears, let's say, they might be in that twilight zone. The bigger issue, though, I think, is the planet going to have water? If the planet formed so very close to its star, I have to worry that there just wasn't that much water to get incorporated into the planet because the forming material was presumably quite hot. And so the question is, maybe there are comets in the outer part of the solar system that crashed into the planet and brought the planet water. So the biggest question I have about Proxima Centauri's planet is, does it have water? Does it have an atmosphere? And those are really the two biggest questions that I think we would like to answer about that planet. Because if the answer is yes to both of those, then I think you've got a real chance of having some form of life on that planet.
Okay, now when I was in elementary school, we learned that our solar system is probably a very average, normal solar system. All the planets moving in perfect circles around the sun, with rocky planets toward the center and, gas giants like Jupiter toward the outside. But wasn't that overly simplistic? Now we have the TRAPPIST-1 solar system with 7 Earth-like planets going around it. So could you explain how is this possible that we could have 7 Earth-like planets going around a star when we once thought that our solar system was like a template? It was an average solar system. Were we wrong, horribly wrong?
We were horribly wrong, and we in fact saw that with the discovery of the very first extrasolar planet going around a sun-like star. That was 51 Pegasi back in 1995. It's a giant planet, a bit smaller than Jupiter, that is closer to the star than Mercury is to the sun. So what we have learned is that there are all these solar systems out there that bear no resemblance to our own. And the TRAPPIST-1 system, which was announced in February of 2017, has 7 planets that are more or less the same size as Earth. They're all located very close to the star. A number of those planets are in the habitable zone, which means if they've got liquid water, they could have some form of life because their temperature is such that they can allow liquid water to exist on the surface. So it's a solar system that's very interesting. It's only about 40 light years away. It's about 10 times farther than the Proxima Centauri planet.
So our original understanding of the so-called average solar system is wrong, right? I mean, we have all sorts of oddballs out there. In fact, the creators of Star Wars, the movie, were criticized because they showed a planet going around a double star, and they thought that would be unstable. So astronomers poo-pooed the movie Star Wars, but now we have solar systems with 4 suns. I mean, isn't that incredible? A solar system with not 1, not 2, not 3, but 4 stars going around it? That's incredible, right?
Yes, indeed. The Kepler spacecraft discovered a number of planets going around double stars, which some astronomers have said was not possible. Although I should point out that back when I was in graduate school, there was a professor that told me that since we know far less about planet formation than we should keep an open mind about these questions. Now, this was before any planets had been found outside our solar system, but the point is, he was right. And the fact is there are double stars, binary stars, with planets. The first example was the star called Kepler-16, which has 1 planet going around 2 stars, both smaller and fainter than the Sun.
Okay, now let's talk about LHS 1140, yet another super Earth revolving around a white dwarf. So first of all, what is a super Earth? And then tell us about this latest discovery.
Well, this is another example of how our solar system is perhaps not typical. There are no super Earths in our solar system. There is a big gap in our solar system if you were to arrange the planets by size. There's a big gap between Neptune and the planet Earth. Neptune is 4 times the diameter of Earth. Earth, of course, is exactly the diameter of Earth. There's nothing in between in our solar system. But we've discovered a number of planets going around other stars that are in that gap. They're larger than the Earth, but smaller than the planet Neptune. And one of them goes around this red dwarf that's located 41 light years away in the constellation Cetus, named LHS 1140. And this super-Earth is notable because it, too, is in the star's habitable zone. It's also notable because the planet is very dense, denser than any planet in our solar system.
Okay, Ken, we have to take a short commercial break, but after the break we're going to continue our discussion of planets discovered in outer space, and also an oddball star that some people think may have an alien spacecraft revolving around it. So we'll talk about aliens in the next segment as well. Welcome back to Science Fantastic with Professor Michio Kaku. In this hour, we're talking about the universe as we've never seen it before. In the last 10, 15 years, we've been flooded with information about other Earths out there in outer space. 3,600 by last count, 3,600 exoplanets discovered orbiting other stars in outer space. In fact, on average, we have 1 planet per star. So think about that. When you look at the heavens tonight, when you look up in the heavens, realize that on average, each star, on average, has a planet going around it. And 1 out of 20 of them have Earth-like planets going around them. And so the planet Earth may have doppelgangers, that is, twins of the Earth in outer space. So with us today to talk about this is astronomer Ken Croswell, author of a number of great books, including The Alchemy of the Heavens. So, Ken, where we last left off, we were talking about yet another super-Earth found orbiting a star in outer space. This one is LHS 1140. What's so different about this super-Earth compared to the approximately 20 other super-Earths that have been discovered so far?
Well, one interesting thing about it is that it is very dense. It's about twice as dense as Earth, 12.5 grams per cubic centimeter versus 5.5 grams per cubic centimeter for the Earth. And that suggests that it's a world of iron and rock, just like the Earth, but the proportion of iron is probably a good deal greater on this planet than on the Earth. Now, the big question about this planet is, as with the Proxima Centauri planet, does it have water? Does it have an atmosphere? Because if it does have water, if it does have an atmosphere, it's in the star's habitable zone, and it could have some form of life. And again, that planet is located 41 light years away, so about 10 times farther than the Proxima Centauri planet.
Okay, now, some people say that some of these planets that we've discovered may not have life on them because, well, they may not have a magnetic field. We're blessed with having lots of iron in our core, meaning we have a magnetic field that can deflect solar flares. Now, this new planet, LHS 1140, if it's quite dense and it has an iron core, isn't it possible, therefore, that it has a very healthy magnetic field, which could then deflect solar flares and other kinds of radiation? What are your thoughts?
That makes sense to me, yes. I see no reason why this planet should not have a magnetic field, although let's keep in mind that the planet Venus, which is very similar in size to the Earth, does not have a magnetic field. So you never know. But I suspect even if there were no magnetic field, you could probably still have life. I'm not convinced that a magnetic field is essential for life on a planet, at least not primitive life.
Okay, well, it is orbiting around a red dwarf, and as we said before, red dwarfs are active, they have solar flares, and a magnetic field would be really handy to deflect some of the radiation coming from that red dwarf, right?
Well, yes, but on the other hand, maybe that radiation speeds up the development of life, increasing the genetic mutations, and so maybe life goes from being primitive to advanced faster than happened here on Earth. And who knows, maybe the life forms on LHS 1140 are so advanced that they want nothing to do with us because we are just too primitive for them.
Okay. And what about LHS 1140? Like, how big is it? Is it like maybe twice the size of the planet Earth? And what are the chances that one day we'll be able to pick up the elements in the atmosphere? Well, we have to take a short commercial break, but after the break, I'm going to talk about atmospheres of the super-Earths. And then let's say a few things about Tabby's star. Is it a sign of intelligent alien life creating a gigantic shadow? Well, we'll find out in the next segment of Science Fantastic. Welcome back to Science Fantastic with Professor Michio Kaku. In this hour, we're going to explore the universe as you've never seen before. We have encyclopedias of all the thousands of exoplanets that have been discovered in outer space. Some of them look very close to the planet Earth. And with us today to talk about these things is astronomer Ken Roswell, author of the book, The Alchemy of the Heavens. So, Ken, we were talking about exoplanets, but of the ones we've discovered so far, which one do you think is the closest to the planet Earth? In size, perhaps in terms of its atmosphere? Are there any super-Earths that have been discovered that look suspiciously close to the planet Earth?
Well, to be honest, no. We haven't really found the perfect planet yet because these planets that we have been talking about over the last few minutes, they all go around stars that are quite different from the sun. They go around these red dwarf stars. And even though we are hopeful that red dwarf stars can have life-supporting planets, we're not 100% certain of that. In contrast, we do know that bright yellow main sequence stars like the sun, they do have the potential to support life-bearing planets because, hey, we live on a life-bearing planet that goes around a yellow G-type main sequence star. And so I'm hopeful that in the future we are going to be discovering planets like the Earth that go around stars like the sun and located in those stars' habitable zones. I think then I'll be much more optimistic that, yes, here's a planet that just maybe may have some form of life, perhaps even intelligent life. We haven't done that yet. We haven't made that discovery yet. These planets that we've been talking about over the last few minutes are very interesting because they are located in the habitable zones of their stars, and they are either Earth-size or a bit bigger than the Earth, and that's all very good, but they go around stars that are very different from the sun. So I'm still awaiting the discovery of a planet like the Earth going around a star like the sun. We're not there yet.
And some people think that one day we'll be able to determine the atmospheres of these super-Earths, whether or not they contain oxygen or water vapor. And so the question is, how do we determine the chemical composition of the atmosphere of a planet which is trillions of miles away?
Well, fortunately, the molecules in that atmosphere emit characteristic and absorb characteristic wavelengths of light. And by measuring the wavelengths coming from those planets, we should be able eventually to determine the composition of the atmospheres. But as you point out, the atmosphere is very important for determining what the planet is like. If we didn't know anything about the Earth other than what's in its atmosphere, we might very well come to the conclusion that, hey, this is a very interesting planet because there's oxygen in the atmosphere, and oxygen is a very unstable element in an atmosphere because it's very reactive. It readily reacts with the surface of the planet. And so if we see oxygen in another star's planet, that is a very strong sign that there's life there, because it's only life here on Earth that pumps the oxygen into the air that we now breathe. And if all life on Earth were to disappear, then so would the oxygen. And so detecting oxygen, large amounts of oxygen in another planet's atmosphere, would be a very strong sign of life on that planet.
Okay, now let's talk about something which is causing a certain amount of controversy in the astronomical community, and that is Tabby's star. It's about 1,300 light years from the planet Earth. In the year 2011, a shadow was formed in front of the star which dimmed starlight by 15%. That was rather strange because Jupiter only casts a shadow in front of our sun and dims starlight by 1%. So something incredibly large went in front of the star in the year 2011. 2 years later, in 2013, something again went in front of that star. Starlight diminished by 22%. That's colossal. And so people began to scratch their heads. In 2015, there was no data because, unfortunately, the Kepler space satellite had a malfunction. So now, 2 years after that, all telescopes that can are being tuned to Tabby's star in 2017. And again, right on schedule. 750 days later, we're seeing a drop in starlight, this time only 3%. So here is the killer question that people are asking. What can cause starlight to drop by 22% in front of a distant star and have starlight dim every 750 days? What are your thoughts? This is the question that is puzzling a lot of astronomers because the tabloids are now getting wind of this, and they're talking about alien civilizations in outer space. But what are your thoughts? What could possibly dim starlight by 22%? Again, we have to take a short commercial break. Sorry about that. But after the break, let's talk about, well, can alien life dim starlight by 22%? Welcome back to Science Fantastic with Professor Michio Kaku. Our special guest today, as we explore the universe, is Dr. Ken Croswell, author of the book, The Alchemy of the Heavens. We're talking about some of the recent astronomical discoveries, in particular, new Earths. Earth-like planets being discovered in outer space. However, there's one anomaly that is causing a lot of astronomers to scratch their heads. There's a star called Tabby's star. It's about 1,300 light years from the Earth, and every 750 days, starlight dims, not by 1%, which is what Jupiter would do, but 15%, 22%, and it's dimming right now. Even as we speak, it is dimming by 3%. Now, Jupiter can cause starlight to dim by about 1%. So here's a question. Maybe you know the answer out there. Maybe you can make a little bit of history by publishing your answer to this question. What can cause starlight to dim by 22%? So, Ken, do you have any thoughts? Because a lot of astronomers are simply scratching their heads right now.
Well, I don't have any profound thoughts other than to say that probably the answer is going to be much more prosaic than alien structures and megastructures in space. I don't really understand why an alien civilization would need to construct such a huge device as to block 20% of its starlight. But as you suggested, maybe it's some sort of swarm of comets. Maybe it's something like, I don't know, maybe something like Epsilon Aurigae, which is this eclipsing binary star in the constellation Auriga. And every 27 years, a large object passes in front of that star and blocks the light substantially. Because you had just noted that this dimming seems to have a period of about 2 years. So whatever is causing this dimming is presumably going around the star once every 2 years. So I think that's going to be a major clue. Obviously, the good thing about this star is we can keep observing it, and we'll be able to find out in real time what it is. So, if indeed it continues to dim once every 2 years, then we'll see that happen again in 2019 and then 2021, and that will be a major clue as to what is going on around this star.
Okay, and you mentioned that, well, if aliens do create an object that can dim starlight by 22%, then why would they do it? Well, according to Freeman Dyson, professor of physics at Princeton's Institute for Advanced Study, maybe they want energy from the mother sun, all the energy, not just a sliver of the energy that they get on their planet, but they would encase the entire sun with a gigantic sphere called the Dyson sphere, or they would have a swarm of small satellites that absorb as much starlight as they can, millions of small satellites absorbing starlight. But, that's science fiction. No one knows for sure what is causing that. But if you in the audience could figure it out, you may get famous by publishing the solution of why starlight can dim by 22% when even Jupiter dims light from the sun by just 1%. Okay, well, also talking about the solar system, the Juno spacecraft orbiting Jupiter has some rather cool pictures of Jupiter. So go to the web and look up the Juno spacecraft, and some of these pictures are rather bizarre, right? They've taken pictures of Jupiter from the poles, the north and south poles of Jupiter, and, well, Ken, what did they find?
Well, they found something that didn't look very much like Jupiter. If you look at one of the poles, it reminds me more of Neptune, because Neptune is a blue planet, and the pole of Jupiter is also blue, and it's got these big storms going across it, these cyclones they're bigger than the moon. In fact, some of them are bigger than the planet Mars. So it's a very active planet. It's part of the planet that we just hadn't really seen well before. And the reason that Jupiter can have such big storms is, of course, Jupiter is such a big planet. It's the largest planet in our solar system, and it has a huge amount of rotational energy because Jupiter spins faster than any other planet, much faster than the Earth. It takes 9 hours and 55 minutes to spin once. So if you lived on Jupiter, you wouldn't have much time for an 8-hour day. The day only lasts about 10 hours. But there's a lot of rotational energy on Jupiter, and that obviously is manifested in the bands of Jupiter and presumably in these newly discovered cyclones at the poles of Jupiter.
Well, so the universe, once again, is more interesting than anyone previously thought. Now, when I was a kid, we learned that there are moons, there are planets, and there are stars, and there's a huge gap between them. But now that we've seen 3,600 planets orbiting other stars out there in the heavens, we realize that maybe there's a continuum. It's just not one category versus another category, but maybe a continuum. And if you go from Jupiter to the super Jupiters to the next level, which is brown dwarfs, a failed star, and beyond the brown dwarf you have real stars. So what is the dividing line? Is there a very clear dividing line between failed stars and successful ones, between brown dwarfs and, for example, our sun, which is a main sequence star?
Well, there's new information on this because astronomers have actually just recently measured the masses of a number of red and brown dwarfs near the sun. And they find that the dividing line between the two is 6.7% the mass of the sun, which is a bit less than we had thought. Above that, if you're born with more mass than 6.7% solar, you get to be a successful star, sustaining nuclear reactions the way the sun does. If you are so unfortunate as to be born below that mass, you will still shine for a time, just from the heat of your formation, but then you will fade and cool, and you are destined to be a failed star, known as a brown dwarf. So we do have new information on that, and that is, it looks like the dividing line between successful stars and failed stars is 6.7% the mass of the sun.
Well, unfortunately, that's it. So, Ken, once again, thank you so much for being on Science Fantastic.
You're very welcome, Michio.
Okay, once again, our special guest today was Dr. Ken Croswell, author of a number of great books, including The Alchemy of the Heavens. See you next week.